Hello students, in 11th Chemistry, lesson 1 already we have completed, that is basic concepts of chemistry and chemical calculations. And today we are going to start the lesson number 2. Lesson number 2 is quantum mechanical model of an atom. That is lesson number 2. What is the topic? Quantum mechanical model of an atom. Dear students, in this lesson we are going to discuss the various models of an atom. We know that everything around us is termed as matter. நம்ம சுத்தி இருக்கிற எல்லாமே matter, and matter is made up of atoms. So atoms are the fundamental particles of any matter. Okay, so about the structure of atom we are going to see now. And about the structure of atom, various scientists have proposed various atomic models. And the first attempt in deriving the structure of an atom was made by a scientist called John Dalton, who was the first scientist studied about the structure of an atom. Students, according to John Dalton, atoms are considered to be indivisible particle. Okay? What he has told, according to John Dalton, atoms are considered to be indivisible particle because at that time the subatomic particles such as protons, electrons and neutrons were not discovered. So he told that atoms are considered to be an indivisible particle. But later, another scientist called J.J. Thomson, so he discovered the presence of electron in an atom through an experiment called cathode ray experiment. So from that cathode ray experiment, he has found that atoms has electrons. That is a subatomic particle present in an atom. So according to J.J. Thomson, an atom is considered to be a sphere of positive charge. It is similar to that of watermelon or guava fruit model. Okay, in watermelon, the red color portion is there, no? That is similar to that of the positive sphere of an atom, whereas in that positive sphere, the electrons, that is the negatively charged electrons, are embedded. So according to J.J. Thomson, atom is considered to be a positive charge in which the electrons are embedded. Then later on, this model also had some drawbacks. So in order to rectify that drawback, another scientist, he is called as Rutherford. Rutherford performed an experiment called alpha ray scattering experiment. This is the experiment done by a scientist called Rutherford. So what is the experiment done by Rutherford? It is called as alpha ray scattering experiment. What he will do is, he will take a beam of alpha ray. A beam of alpha ray is passed through a thin gold foil. Or gold sheet எடுத்துட்டு அதன் வழியா alpha ray was passed. Okay, at that time he observed that some of the alpha rays are allowed to pass through the gold foil, whereas some of the alpha rays are deflected by an angle, whereas some of the alpha rays are deflected in the same angle, that is 180 degree. So from this experiment he proved that at the center of an atom there is a tiny positively charged species is there, and that is termed as nucleus. அதாவது நியூக்ளியஸ் இருக்கிறதுனால this alpha ray is not able to pass through this gold foil, so that it is deflected in the same angle. Okay, but something is deflected by a certain angle, no? It is due to the presence of electron. So he confirmed that electron is revolving around the nucleus, and some of the alpha rays were allowed to pass through the gold foil, no? It is due to the empty space. So 3 observations he has given. What are those observations means? Most of the alpha rays were allowed to pass through the gold foil, whereas some deflected by an angle, whereas some of the alpha rays are deflected in the same angle, that is at 180 degree. So from these observations, he proposed that every atom consists of a positively charged tiny nucleus at the center. Over atomic center, what is there? Nucleus is there, and the electrons will be revolving. Okay, the electrons will be revolving around the nucleus. So this is the model proposed by a scientist called Rutherford. But according to electromagnetic theory, whenever a charged species is continuously moving, or a charged species continuously move, it can lose its energy. It's we know, okay, when we are working continuously, if we work continuously for around 5 or 6 hours, what will happen to us? Our body will lose its energy, and finally we won't have any energy. Likewise, when the electron is continuously moving, it will lose its energy, and finally it can drop into the nucleus. If the electron dropped into the nucleus, means what will happen? It will lead to the disk rupturing of the structure of an atom. Atomic structure sidanju. That is not possible because atoms are very stable one. So this method is also a failure. The method proposed by Rutherford is also failure since it has this disadvantage. He told that electrons are revolving continuously, so that energy will be lost continuously. Finally, the electron can fall into the nucleus. That will cause the breakage of nucleus. So this method is also a failure one. Then again another scientist. Now he is coming to explain the structure of an atom. He is called as Rutherford. Rutherford is going to explain the structure of an atom. Okay, sorry, not Rutherford, Niels Bohr. Okay, so Niels Bohr model of an atom. What we are going to see now? Niels Bohr model of an atom. Okay, what was the major disadvantage in Rutherford model? Main disadvantage enna pathona, the electrons are continuously moving, so that they are losing their energy. So in that point, this Niels Bohr is giving a modification. The energy is not lost continuously. Energy continuous loss agala. The energy will be lost only in packets or in bundles. So based on Einstein and Max Planck, there were two scientists. They are working in the area of light. So based on their observations, Niels Bohr is telling that no atom or no electron is losing its energy continuously. Only the energy is lost in packets or bundles of energy, and that packet or bundle is given by a term h nu. Okay, so the energy is lost only in the bundles or packets of energy. Okay, so the energy of an electron is quantized. So quantization is the main concept done by Niels Bohr. That is the first postulate of Niels Bohr atomic model. Energy of an electron is quantized, and he mainly did this model for one electron system. One electron means, look at hydrogen. What's the atomic number? The atomic number of hydrogen is 1, which means how many electrons it will have? It will have only one electron. So this model was first applied to hydrogen atom. Then based on hydrogen atom, for other atoms also he applied the same method. Okay, okay. Now we are going to see about the observations of Niels Bohr atomic model. What is the first observation I told you? Energy of an electron is quantized, which means what? Energy is not lost continuously. Only the energy is lost in the form of packets of energy or bundles of energy. That's the first observation. Energy of an electron is quantized. In which unit it is quantized? It is quantized in the units of h nu. Here h is called as Planck's constant and nu is the frequency. Okay, here energy of an electron is quantized. And in the case of Rutherford, he told that electron is revolving around the nucleus. He didn't tell about where it is revolving, the place where it is revolving, he didn't say. So that was given by Rutherford. He says that electrons are allowed to move only in a certain path. Those paths are called as orbits. Electrons, where they will move only in orbits, the electrons are allowed to move, and those orbits are stationary. For example, if this is nucleus, means this is orbit in which the electrons will move. Dear students, this is nucleus. Here it is the circular path and it is stationary in which the electron will be moving. Okay, so that circular path is called this orbit. Okay, okay. And we saw now the energy of electron is quantized. Then third point. Third point is it's very important, but it has no theoretical support. Only the point is given. At that time, Niels Bohr was unable to explain the third point. According to him, the angular momentum in the physics you might have studied MVR, mass, velocity and radius. The angular momentum of an electron will be equal to the integral multiple of h by 2 pi. The angular momentum of an electron is equal to the integral multiple. Here n is an integer. It may be 1, it may be 2 or it may be 3 based on the orbit. First orbit means n value will be 1. Second orbit means n value will be 2 and so on. Okay, so this is the third point. What he is telling in the third point? The angular momentum of an electron, that is MVR, is the integral multiple of h by 2 pi. That is the third postulate given by Niels Bohr. What are 3 points I have told you? First one is the energy of an electron is quantized. Then electrons are allowed to move only in a fixed paths. Those paths are called as orbit. Then third point, the angular momentum of an electron is the integral multiple of the term h by 2 pi. Then fourth point we are going to see. It's very important point. The electrons will be, second point we saw now, the electrons are circulating only in the stationary path. So as long as the electron remain in the same path, there will be no loss of energy. As long as the electron is ஒரே path there will be no loss of energy, but it can jump from higher orbit to lower orbit or from lower orbit to higher orbit. It is a nucleus, means imagine this is the first orbit and this is the second orbit. Electron is here and it can also be here. The electron can jump from higher state to lower state or from lower state to higher state. Let us see this condition. When an electron can jump from higher state to lower state. In the higher state, the energy will be high. So when it is jumping from the higher state to lower state, this we can take E2 and this we can take E1. In the E1, the energy of electron may be somewhat lesser. So the difference between energy E2 minus E1 can be taken as h nu. In the higher state, the lower state, when electron is jumping, the excess energy is emitted in the form of radiation. That is the packet of energy h nu. Higher state to lower state, when an electron is jumping, the excess energy is emitted in the form of radiation. That is h nu. Then from this we can find out the nu value, frequency. Nu is equal to E2 minus E1 divided by h. Likewise, we can study in the reverse way. When the electron is jumping from lower state to higher state, lower or higher, in the higher state the energy is excess, so that excess energy we have to supply for this electron to jump from the lower state to higher state. Okay, so these are the 4 observations of Niels Bohr atomic model. What are they? Energy of an electron is quantized. Then electrons are allowed to move only in a certain path. Those paths are called as orbits. Then third point, the angular momentum of an electron is integral multiple of h by 2 pi. So MVR is equal to nh by 2 pi, but for this no explanation is there. Okay, then fourth one, as long as the electron remain in the same orbit, there is no loss of energy. But when an electron is jumping from higher state to lower state, the excess energy is emitted in the form of radiation, that is h nu. From this we can find out the value of nu. Nu is equal to E2 minus E1 divided by height. Likewise, when an electron is jumping from lowest state to highest state, we have to supply more amount of energy to enhance that jumping process. Okay. Then by using these terms, next Niels Bohr is going to derive the radius and the radius of an orbit as well as the energy of an electron. So those two terms we can derive by using what? By using this Niels Bohr atomic model. The derivation is so large that you will study in your 12th standard atomic physics unit. Here only you will see the last term for radius as well as the energy. Radius Rn. Okay, radius of an orbit. N means first orbit means n value will be 1, second orbit means 2, and so on. Okay, so from the Niels Bohr atomic model, the radius of n orbit is given by 0.529 n square divided by z, and the unit is Armstrong. So this is the term which is used to calculate the radius of nth orbit. What is the term? 0.529 n square divided by z, Armstrong. Okay, and also the energy term En, that is equal to minus 13.6 then z square divided by n square. The z na enna? Z na atomic number. Okay, atomic number of the species for which we are finding out the energy. And here the unit is electron volts per atom. Another unit, kilojoule per mole. In that only there is a slight difference in unit value of mole. So when we write in kilojoule per mole unit, En will be equal to minus 1312.8. Then remaining everything same, z square divided by n square. Instead of electron volt per atom, we have to write kilojoule per mole. Okay, so these three are the important equations we can derive from Niels Bohr atomic model. Radius of nth orbit, energy in terms of electron volt per atom, and energy in terms of kilojoule per mole. Okay, so with this Niels Bohr atomic model over. 4 observations we have seen, then radius and energy we have seen. And now we are going to see about the limitations of Niels Bohr atomic model. This is also very important 3-mark question. What are the limitations of Niels Bohr atomic model? Students, in the beginning itself I told you that Niels Bohr derived his concept only for what? For what kind of atoms? For one electron systems. In this species one electron. For example, hydrogen. Then lithium 2+. So these species will have one electron, and he didn't apply his concept to polyelectron. Many electron system he didn't apply. That is the first disadvantage or limitation of the Niels Bohr atomic model. It is applicable only to one electron system. It doesn't explain about polyelectron system. That is the first limitation of Niels Bohr atomic model. Then second one, splitting of spectral lines in 2 different fields. One is electric field and the one more is magnetic field. When an atom is subjected to radiation or spectra, spectra is similar to scanning. Our body we are scanning, no? Likewise for atoms and molecules we take spectra. So in that spectra, splitting takes place. Splitting in the presence of electric field and also splitting in the presence of magnetic field. Splitting in electric field is called as Stark effect. Stark effect now splitting in electrical field. Whereas Zeeman effect now splitting of spectral lines in magnetic field. About these two terms, Stark and Zeeman, no explanation is given by Niels Bohr. That is the second limitation of Niels Bohr atomic model. The first one is it is applicable only for one electron system. The second one is there is no explanation about the splitting of spectral lines in electric and magnetic field. Or simply we can say it did explain Stark effect and Zeeman effect. That is the second disadvantage of Niels Bohr atomic model. Then third limitation is in the on past page we saw the angular momentum, that is mvr, that is equal to nh by 2 pi. The angular momentum of an electron is equal to the integral multiple of the term h by 2 pi. For this term, no explanation was given by Niels Bohr. So these three are the limitations of Niels Bohr atomic model. What are they? First one, it is applicable only for one electron system. It doesn't explain Stark effect and Zeeman effect. And finally, there is no explanation given why mvr is equal to nh by 2 pi. So these three are the limitations of Niels Bohr atomic model. Okay. Then next, an important concept we are going to see. That is called as wave particle duality. What is the meaning of the term dual? Dual means two. Okay, so Einstein, he is mainly dealing with light. He had his researches only in the field of light. Okay, and he told that light has dual character, and those dual characters are particle and wave. What are the dual characters possessed by light? Particle character and wave character. Then we must think ourselves, particle na enna, wave na enna. What is called as particle and what is called as wave? Simply take a stone. Stone is said to possess particle character. Enna property? It occupies a definite space. When we place it somewhere, it occupies a definite place. That is the essential quality for a particle. Wave. Can we see waves? Sound waves can we see? No. Likewise, waves we cannot see, so that it doesn't occupy any space. Okay? So light is said to possess dual character. Those dual characters are particle character and wave character. So this is the idea possessed by Einstein. So Einstein is light particles, and light particles are also called as photons. Photons are light particles. Okay, photons are said to possess dual property, that is particle character and wave character. Now another scientist called de Broglie, what he is telling is the same dual character is also possessed by all the material particles. Enna particles they possess dual character. They possess particle character as well as wave character. So based on this, another concept we are going to see, that is wave particle duality. Wave particle duality. So what is wave particle duality? In our universe, okay, it may be a small electron, proton, or a leaf, or stone, chalk piece, whatever it may be. All the materials are said to possess both the characteristics. One is particle character and the one more is wave character. So about that we are going to see now. Okay, so here we mix two concepts. The first one is by Einstein. Okay, according to Einstein,